This video takes a deeper look at strategies for dialogue management. I'll begin by going over a simple finite state dialogue manager, and then move on to discussing more recent techniques for dialogue state tracking and dialogue policy. I'll close by talking about different ways that dialogue systems can manage both user and system errors. Dialogue managers are sort of the mission control of task-based dialogue systems. They take in all of the new and existing information available to them and decide what to do with it. They can range from simple to complex depending on the given problem and task domain. The simplest dialogue management architecture is the finite state dialogue manager, so I'll start out by covering that before moving on to a deeper discussion of more complex dialogue state tracking and dialogue policy. Finite state dialogue managers are basically just finite state automata in which the states are questions that the dialogue manager asks the user, and the transitions are actions that are taken depending on how the user responds. You might have already learned a bit about finite state automata in your prerequisite courses, but if you haven't, we'll also review them in next week's module. Since the states are entirely comprised of questions from the dialogue system, this means that the system has full conversational initiative. It's impossible for a user to knock it off course because it'll just ignore or misinterpret inputs that aren't direct answers to its questions. If you recall from earlier this week, system initiative dialogue systems aren't really everyone's favorite because they can get pretty annoying for users who want to do something that isn't part of the predetermined course. However, for this reason, these types of dialogue managers are also excellent for getting the job done, at least from the system's perspective. Here's an example of a finite state dialogue manager for the travel booking system we've discussed throughout this module. Note that this dialogue manager has a predetermined path, and in most cases doesn't even provide the user with options. It just assumes that they'll comply and provide the information requested. It begins by asking the user for their departure city, followed immediately by their destination and their departure date. It then asks a yes or no question to determine whether the user is going on a one-way trip. If we say, for example, that it is, the system proceeds to ask one final yes or no question to make sure that it has the details correct. If it does, it books the flight, and if it doesn't, it restarts the entire process again. One thing that wasn't present in the previous example, and that many finite state systems do allow, was a universal command, for example, to seek help, start over, correct the last input, or quit. These can be really helpful for reducing user frustration in system initiative dialogue systems. So to summarize the pros and cons of finite state dialogue managers, their advantages are that they're easy to implement and sufficient for simple tasks. In some cases, you really just don't need a super fancy dialogue system, and finite state dialogue managers are great for those cases. However, their disadvantages are that they can be awkward and annoying at times, and they also struggle to handle complex inputs. More advanced dialogue managers comprised of a dialogue state tracker and dialogue policy are more common in modern dialogue state architectures, so I'll describe those in more detail next. A dialogue state tracker determines the current state of the task frame. It keeps a running tally of which slots have been filled and with what information. This tally counts information that has been received over the course of the entire interaction, not just the present input. It also remembers the user's most recent dialogue act, which can be very handy when selecting what to do next. We can visualize what a dialogue state tracker might look like in action here. Let's start out with an empty dialogue state tracker, like what we would expect to see at the beginning of a dialogue, and our set of dialogue acts from the previous video. Then let's go ahead and receive our first input. Our natural language understanding module interprets this input and decides that this is an inform act containing a slot value, expensive, for the price slot in our frame. It selects a response based on this information, and the user responds with some new input. The system interprets this input and adds an additional slot value, Turkish, to the cuisine slot in our frame. Again, the system selects a follow-up response, and the user provides some more input. The system adds another slot value, Chicago Theater, to the task frame. Finally, the system decides it probably has enough information to perform the requested task. It creates an affirm act and fills it with the slot values that it knows to make sure it hasn't interpreted anything incorrectly. The user confirms that this information is correct, and the dialog terminates. One challenging thing that the NLU component and the dialog state tracker have to do together is to detect user corrections and incorporate them accordingly into the current frame. A lot of times users will correct errors by repeating or reformulating their utterance. However, they also tend to hyperarticulate when they're making corrections, which actually makes things harder for the ASR module because hyperarticulations don't follow the same patterns as regular speech. So another thing to look out for when trying to identify corrections is low ASR confidence. You can also check for paraphrases, the word no, or swear words. The dialog policy is the other major component of modern dialog managers, and its goal is to determine what action the system should take next, given the information it has received from the dialog state tracker. This can be formalized by the equation you see here, where the selected action, A sub I prime, is the action with the maximum probability of occurrence, given all of the actions and utterances up until the current point. We can simplify the dialog history by representing it as the current state of the frame. Once again, the slot fillers and utterances in these equations will generally be represented as vectors. The probabilities can then be estimated using machine learning or neural network classifiers, or sometimes reinforcement learning may be used instead. Even though recent dialog policies are pretty sophisticated, they still make mistakes sometimes, and as we already saw, users make mistakes too. So dialog managers can handle mistakes in several ways. A good first step is usually to make sure the user's input has been interpreted correctly, either through explicit or implicit confirmation. Explicit confirmation is when the system asks the user a direct question to confirm its understanding. Two examples of this are where the system is basically repeating what the user said to make sure that it has interpreted the input correctly. Implicit confirmation is done more through conversational grounding. It is typically implemented by repeating what it understood as part of the next question. Some examples of this are There are advantages and disadvantages to both explicit and implicit confirmation. Explicit confirmation generally makes it easier for users to correct the system's mistakes, but it can also lead to some awkward, unnatural exchanges. It also extends the length of the conversation, which isn't generally desired in task-based dialogue systems. Implicit confirmation sounds more natural and is also more efficient. However, it's more difficult for users to correct mistakes since the confirmations are embedded in other questions, so there might end up being more downstream confusion from using this strategy. Sometimes the dialogue manager will simply have no idea how to handle the user's input, and this is most often the case if a user says something that is completely outside the realm of the expected context. In these cases, systems can reject the user's input and then follow a strategy of progressive prompting to elicit the desired information. In progressive prompting, the system gradually gives the user more guidance regarding the information that it needs. An example of this is shown. Aside from the strategies already discussed, a few other strategies for error handling include rapid reprompting, explicitly confirming low-confidence ASR hypotheses, and designing thresholds based on the cost of making an error. These are all modeled after behaviors that humans engage in during similar situations. For example, if you're not sure what someone said, but you can also tell from context that it isn't overly important to know what they said, you're probably not incredibly likely to interrupt them and ask them to repeat what they said. So overall, this video covered a variety of different techniques for dialogue management, as well as some useful strategies for error handling. High-quality dialogue management is crucial to creating high-quality dialogue systems, so it is important to think carefully about which strategies will work best for your application and task domain when creating your own system.